Imagine you are an investor,
Right.
and you're looking at two brand new startup companies.
Okay, I'm with you.
So Company A takes their entire initial funding and just blows it. I mean, they buy a celebrity-filled Super Bowl ad, a flashy billboard in Times Square.
The classic massive launch
Yeah,
party.
exactly. And they don't even really have a functional product yet.
Yeah.
But to the outside world, they look incredibly successful. Everyone is talking about them.
Right, they look like a sure thing.
But then meanwhile, you've got Company B, and they spend $0 on marketing. Wait, I mean, nobody even knows they exist. Instead, they're just quietly sinking every penny they have into building this, state-of-the-art underground data center.
And a flawless logistics network.
Yes. So what happens when the market shifts?
Well, I mean, when the inevitable recession hits a few months later, Company A just evaporates overnight. They have absolutely no actual foundation to stand on.
Right.
But Company B, they survive the crash because they actually own the underlying infrastructure.
Which brings us to today. Welcome to today's deep dive. We are going to look at a literal weed that proves why Company B's strategy is the ultimate biological blueprint for survival.
It really is.
Our mission for you in this session is to completely redefine what resilience and growth actually look like. And we're going to do it using this really fascinating micro case study.
Yeah, the source material for this is incredible.
It is. It's a single entry from a gardening journal by an author named Ang, and it's titled Notes on Gardening, Part 872.
And just right there, the fact that we are looking at observation number 872 implies this remarkable dedication to, the slow, methodical study of the natural world.
Yeah, it's a lot of notes.
Right. This isn't someone just casually glancing at a flower pot on your windowsill. This is someone who is paying deep attention to the really subtle mechanics of how things grow.
Okay, let's unpack this. The star of our show today is a plant called the Blue Porterweed, or Stachytarpheta cayennensis, if we're being scientific.
Always good to be precise.
So Ang is doing some routine transplanting, right? Moving these germinated seedlings and cuttings into new pots. And Ang notices this very stark visual contradiction.
Right. The plant looks completely different depending on where you look.
Exactly. Above the soil, the blue porterweed is just entirely underwhelming. We're talking short stems, really slow vertical growth, and these tiny, scrawny little leaves.
Not exactly a showstopper.
No. If you were judging its health purely by surface-level aesthetics, you would assume this plant is just straight up failing.
What's fascinating here is how quickly that observation exposes our own biases.
Oh, totally.
We've been so conditioned to conflate visible growth with actual health. Like, if you see a houseplant with stunted growth and small leaves, your immediate instinct is to intervene.
Right, you want to add fertilizer or, move it to a sunnier window.
Exactly. You just assume it's a weak specimen. But when Ang pulled these specific seedlings out of their pots, the story completely changed.
It's a startup paradox all over again.
Yes. Beneath the soil, totally hidden from view, was this robust, highly developed root system that was aggressively taking over the available space.
I just love that visual. It looks pathetic on the surface, but it's building this incredible infrastructure underneath, which, forces us to ask, what is the plant actually trying to achieve?
Right. Why redirect so much energy downward?
Right. And Ang's notes point out that this specific underground network is a primary trait of what makes a plant hardy.
And when Ang discusses hardiness in this journal, it basically boils down to two specific traits.
Okay, what are they?
The first is a natural resistance to pests, which is a fairly straightforward defensive mechanism. But the second, and much more crucial trait, is that fast-growing root system.
Because it's not just sitting there, right?
No, not at all. The plant isn't just sitting passively in the dirt. It is actively colonizing the soil matrix.
Wow, actively colonizing. Let's look at the biological reasoning Ang provides for this, because it kind of explains the plant's entire worldview.
It really does. It dictates everything it does.
So the blue porterweed is a perennial. And for you listening, unlike an annual plant, which has to sprout, grow leaves, produce seeds, and die, all within a single season, a perennial lives for years.
Right, an annual is on a strict ticking clock.
Exactly. It has to be Company A.
Yeah.
It has to produce flashy leaves and flowers immediately to attract pollinators before the winter frost just kills it.
But energy is a finite resource in biology.
Right. Usually measured in glucose from photosynthesis, right?
Exactly. A plant has to make a very calculated decision about where to allocate that glucose. Because the perennial blue porterweed knows it is playing the long game, it actively prioritizes its root network over rapid leaf expansion.
That's so smart.
By conquering that subsurface area early on, it basically guarantees long-term access to moisture and soil nutrients. It is effectively future-proofing itself.
So it builds this massive underground logistics network. But, I mean, the real test of that infrastructure isn't when times are good.
No, it's when things go wrong.
Right. And a major revelation in Ang's journal details what happens when a severe environmental stressor hits the garden. Specifically, a drought.
Yeah, this is where the rubber meets the road.
Here's where it gets really interesting, because this is where the plant's long-term strategy shifts into acute crisis management.
This is the moment the theory of longevity meets the harsh reality of a changing environment.
So what did Ang notice during the drought?
Well, when the drought set in, Ang noticed that the blue porterweed's already small leaves seemed to stall out completely. The plant was intentionally limiting its own photosynthesis in response to the dry conditions.
Wait, I need to stop you there.
Yeah.
Because this is where the logic starts to feel completely contradictory to me.
How so?
You're saying the plant is intentionally limiting photosynthesis as a strategy. But a leaf is essentially a biological solar panel, right?
Right.
And photosynthesis is how the plant generates glucose. It's literally how it eats. How can intentionally starving itself, turning off its own food supply, be a brilliant survival trait? That just sounds completely counterproductive.
I know, it does sound counterproductive at first, but we have to examine the physical mechanics of how a leaf actually functions.
Okay, walk me through it.
So those biological solar panels come with an exhaust system. To take in the carbon dioxide required for photosynthesis, the leaf has to open microscopic pores on its surface.
The stomata, right?
Yes, the stomata. And whenever those pores open to let the air in, moisture escapes out into the air.
Oh, wow.
This process is called transpiration. It is essentially how a plant sweats.
So wait, the larger the leaf, the more pores it has.
Exactly. And the more pores it has, the faster the plant loses its internal water supply to evaporation.
Ah, I see. So in a drought, leaves suddenly transition from being an asset to being this massive liability.
Precisely. The blue porterweed isn't failing to produce large leaves because the drought has weakened it. It's the exact opposite.
It's actively repressing the growth.
Yes, because producing them would be biologically irresponsible under that kind of constraint. By shutting down the above-ground factory, it radically conserves water.
That is amazing. So returning to our startup analogy, a drought isn't just a tough quarter. It's a full-blown economic recession.
Right. The funding is dried up.
Literally dried up. The plant realizes revenue, or in this case, water, is gone. So it immediately lays off its flashy PR department.
I love that.
It stops printing the expensive marketing brochures, the leaves, just to preserve capital.
And it doesn't just hoard that preserved capital either. It reallocates every single ounce of available energy into pushing its roots even deeper into the earth.
Wow, so it goes on the offensive underground.
Exactly.
Right.
It explores new soil horizons, seeking out hidden water reserves that the surface-level annual plants just simply can't reach. It optimizes for survival by prioritizing the foundation over the facade.
That is just brilliant. But okay, everything we've talked about so far is just the plant's natural programming, right?
Yeah.
Like it's a perennial, it knows how to handle a drought.
Right, it's genetics.
But Ang's journal introduces a final variable that completely changes the scope of this entire deep dive.
The nurture factor.
Yes, the human element. Ang concludes that the perennial nature and the drought were actually secondary factors. The primary reason for this extraordinarily aggressive root system was actually the gardener's specific watering technique.
This is my favorite part of the journal because it takes us from just observing a natural adaptation to understanding how we can actively engineer resilience.
Yeah. So Ang uses a technique called bottom-up watering. Now, for you listening, if you have ever accidentally killed a houseplant by pouring too much water on top of the soil, which I have definitely done.
Oh, we all have.
What Ang is describing here explains exactly the mechanics of what went wrong. So how does bottom-up watering actually work from a physical standpoint?
Okay, so when you water a plant from the top down, gravity pulls the moisture through the soil, sure. But the highest concentration of water remains near the surface, right where the stem meets the dirt.
Right, making it super easy for the plant.
Exactly. The plant's roots don't have to work very hard. They just spread out in the shallow topsoil and drink what comes to them. But bottom-up watering completely flips that environment.
How does Ang do it?
Ang places the seedling pots in a tray of water. And then, through a process called capillary action, which, by the way, is the exact same physics that allows a paper towel to soak up a spill against gravity.
Oh, I know what you mean, where the liquid just creeps up the towel.
Right. The water wicks upward through the tiny air pockets in the soil matrix.
But the crucial detail here is that the heaviest concentration of water remains at the very bottom of the pot, right? Like the surface of the soil might even feel completely dry to the touch.
Yes, that's exactly it. And roots actually possess a specialized sensory ability called hydrotropism.
Hydrotropism, okay.
Yeah, they can literally sense moisture gradients in the soil. So when Aang waters from the bottom, the plant realizes that all the life-saving resources are located beneath it.
Oh, wow.
It receives a very clear environmental cue. If you want to survive, you have to dig.
It's basically reading the room. Or reading the dirt, I guess. The plant senses that moisture gradient and responds by firing all of its growth energy downward. The roots stretch and multiply, aggressively chasing that localized water source.
Right.
The environment that Aang created is literally training the organism's behavior.
If we connect this to the bigger picture, it demonstrates how deeply an organism's physical development is dictated by the availability and location of its essential resources.
It adapts to where the good stuff is.
Exactly. If Aang had taken the easy route and provided all the water at the surface, the blue porterweed would have developed a really lazy, shallow root system.
Right, because why would it bother digging?
Exactly. And when that severe drought eventually hit, the surface soil would have dried up and the plant would have died. It would have been completely unequipped to handle the stress.
It's like a coach putting an endurance runner through high-altitude training.
Oh, that's a great analogy.
Right. By withholding the easy surface-level oxygen, or in the plant's case, the surface-level water, the coach forces the runner's body to build a massive lung capacity.
Right.
It makes the daily practice much harder. And the runner might even look slower and weaker at first compared to someone training at sea level. But when the actual race happens, when the real environmental stress test arrives, they have a biological infrastructure that no one else can match.
It is an induced hardiness. Aang is actively partnering with the biology of the perennial.
Yeah.
By applying the specific controlled stressor of bottom-up watering, the gardener leverages the plant's natural hydrotropism to cultivate a survival strategy.
It's just wild to think about.
Aang's daily habit of where to pour the water completely dictates the structural reality of the plant.
Which brings us full circle back to Aang's initial observation, right?
Right.
Of those tiny, scrawny little leaves.
Right, the underwhelming surface.
Yeah. Once you understand the mechanics of perennial energy allocation, the liability of transpiration during a drought, and the hydrotropic response to bottom-up watering, those small leaves no longer look like a symptom of failure.
Not at all.
They're the visible evidence of a highly optimized system functioning flawlessly.
It fundamentally changes the metric of success. I mean, the plant is thriving precisely because it is ignoring the surface.
So what does this all mean? Why spend this time digging into a random gardening note about a scrawny weed?
It's a fair question.
Because the blue porterweed and Aang's bottom-up watering technique serve as a perfect mirror for how we build our own lives, and our businesses, and our communities.
Absolutely.
It forces us to really examine our obsession with the skyscraper's shiny glass facade, whether you are learning a new skill, or building a team at work, or raising a family. The temptation is always to look for immediate, visible proof of success.
We all want the big, bright green leaves so we can show them off and prove that we're doing well.
Right, we want the launch party.
But true hardiness is rarely visible. The infrastructure that allows any complex system to survive a crisis, whether that crisis is an economic downturn, a personal failure, or a literal drought, has to be built out of sight.
Yeah.
It requires the discipline to focus on the really unglamorous hidden work of deep root expansion.
It is about having the courage to intentionally limit your surface level growth, right? To lay off the PR department when you know that energy is better spent building a solid foundation.
Exactly.
It's about choosing to be a perennial in a culture that constantly demands the immediate gratification of an annual.
And this raises an important question to leave you with today, and it's one that flows directly from Aang's careful observation of the soil.
Let's hear it.
Think about the most important systems, projects, or even the people in your own life right now. If we continue to measure their progress and their value solely by the leaves, the rapid, highly visible results they present to the world, what massive foundational roots are we completely failing to appreciate?